Properties of ionic compounds. Now in this figure 3.7, heating a salt sample on a spatula. Some of the ionic compounds impart color to the flame. And figure 3.8, here testing the conductivity of a salt solution. Usually ionic compounds, they conduct electricity when they are in solution form. For example, sodium chloride when dissolved in water, it will give sodium ions and chloride ions. And due to the movement of these ions towards the oppositely charged electrodes, there will be flow of current through the solution. Physical nature of ionic compounds. Ionic compounds are usually solids, they are hard and brittle. Brittle means break into pieces when pressure is applied. Why are they hard? Because of the strong forces of attraction between the positive and negative ions. Melting and boiling point. They have very high melting and boiling points. What is the reason? The reason is a large amount of energy is required to break the strong interionic attractions. That is, to break the attraction or the ionic bond between positive and negative ions, a large amount of energy is required. Solubility. Electrovalent compounds means ionic compounds which are formed by the transfer of electrons are generally soluble in water and they are insoluble in solvents like kerosene and petrol. Now in this they follow the rule like dissolves like. Ionic compounds will dissolve in polar solvents. For example, NaCl, it is made up of Na plus and Cl minus ion. So it will dissolve in polar solvent, means solvent like water which have positive and negative end. And it will not dissolve in solvents like kerosene and petrol because these solvents are neither ionic nor polar. So ionic compounds tend to dissolve in polar solvents. Polar solvents means which have positive and negative poles. Conduction of electricity. Ionic compounds in solid state do not conduct electricity. Why? Because the ions are held at fixed positions due to strong electrostatic forces of attraction. But ionic compounds either in molten state or in solution, molten state or their solution in water, the ions, the positive and negative ions are free to move. So in molten state or as a solution in water, they can conduct electricity due to the movement of the ions. In molten state, the electrostatic forces of attraction between the oppositely charged ions are overcome due to heat. So these ions are free to move and conduct electricity. And in solution state, the ions are free to move, as a result of which they are capable of conducting electricity. But in the solid state, the ions are at the fixed position, they are not free to move, so they do not conduct electricity in the solid state. Write the electron dot structures for sodium, oxygen and magnesium. First, sodium. Atomic number 11, electronic configuration 281. So valence shell contains only one electron. So its electron dot structure will be sodium and the electron present in the valence shell. If it is denoted by a cross, this denotes the electron present in the valence shell of sodium. So this is the electron dot structure of sodium. Second is oxygen. Oxygen atomic number 8, electronic configuration 26. 6 electrons in the valence shell. So oxygen surrounded by 6 electrons in the valence shell. So this is the electron dot structure of oxygen showing the number of electrons present in the valence shell of oxygen. Third is magnesium. Atomic number 12, electronic configuration 282. This is the symbol of magnesium and the number of electrons in the valence shell is 2. The electrons in the valence shell are shown by cross. So these represent the number of electrons in the valence shell, that is 2. Next question is, show the formation of sodium, this will be sodium oxide, and magnesium oxide by the transfer of electrons. What are the ions present in these compounds? Sodium oxide has the formula Na2O. 2 sodium atoms having 1 electron in the valence shell. Oxygen atom has 6 electrons in the valence shell. Sodium transfers its electron to oxygen. This sodium atom also transfers its electron to oxygen. So each sodium atom gives one electron present in its valence shell to oxygen. So here each sodium atom gets a positive charge, forming a sodium ion. So there are 2 sodium ions, and oxygen accepts 2 electrons from 2 sodium atoms, and it gains 2 units of negative charge, and it has 8 electrons in its valence shell. So 2 sodium ions and 1 oxide ion, and the formula becomes Na2O. Similarly, in the formation of magnesium oxide, number of electrons in the valence shell of magnesium are 2. Number of electrons in the valence shell of oxygen are 6. Now magnesium having 2 electrons in its valence shell, it loses 2 electrons to form magnesium ion and having 2 units of positive charge, and these 2 electrons are given to oxygen. So oxygen gets 2 units of negative charge. So magnesium loses 2 electrons and gets 2 units of positive charge. Oxygen accepts 2 electrons and it gets 2 units of negative charge. So the compound formed is magnesium oxide having the formula MgO. And in the electron dot structure, magnesium ion, this is magnesium ion, and this is the oxide ion having 8 electrons in its valence shell with 2 units of negative charge, and this is magnesium ion having 2 units of positive charge. Now in both these cases, sodium has electronic configuration 281, and when it loses one electron to form sodium ion, the electronic configuration of sodium ion is 28. Similarly, electronic configuration of magnesium is 282, and it loses 2 electrons to form Mg2 plus ions, and the electronic configuration of magnesium ion is 2,8. And oxygen, its electronic configuration is 2,6, and it gains 2 electrons to form the oxide ion O2 minus ion, which has electronic configuration 2,8. Now next question, why do ionic compounds have high melting points? Ionic compounds have high melting points because in ionic compounds the positive and negative ions are held together by very strong electrostatic forces of attraction, and it requires very large amount of energy to break these electrostatic forces of attraction. They usually exist in solid state, and the ions are held together by strong electrostatic forces of attraction. To overcome this high electrostatic forces of attraction, very large amount of energy is required, as a result of which they have very high melting points.